Hi, this is Mrs. Williams, and we're going to go over an example of how to plot a plane in 3D using parametric equations. So the parametric equations describe how to find your x value, your y value, and your z value in terms of t. And what you want to do is pick a t value. So I created a chart just to keep my work organized, and I created the first column for t, and you get to choose any values you'd like there. So I will just do 0, -1, and +1. And then for x, we're going to use this first parametric equation, x equals t, to find it. So if my t value is 0, that means right here I would plug in a 0. So I'll just write out my equation that I'm actually doing here. X equals 0. And in this case, that is your x value. There's nothing to complete or simplify because all there is over there is t. Now when we get to the y and the z, we'll have a little more work to do, but the x starts us out easy. So then we'll go to the next t value that we picked, which is -1, and we're going to do the same thing. We're going to say, okay, well, if t is -1 and I put -1 right there, what would x be? So I'll plug that into my equation and see what I get. And because there's nothing else to do there, I just get x equals -1. And then same thing on the last one. If my t value is 1, then that means x is 1 because x and t are the same thing in this problem. Okay, but what about y? Y is not the same thing as t. Y is equal to -3t plus 6. So I'm going to have a little more work to do. So if t is 0, I'm going to put 0 right here, and then I'm going to simplify this, okay? So it would be y equals -3 times 0 plus 6. I probably should have made that a little bit bigger so I can show my work, but remember, you want to use the order of operations to complete this part, so you would do this multiplication first, -3 times 0, which is 0, and 0 plus 6 is 6, so y ends up being 6. So y equals 6 if t is 0. What would y be if t is -1? Well, we're going to do the same thing. Same process, plugging in -1 for t. So -3 times -1 is what we want to complete first. A negative times a negative is a positive, so we get +3 from this part of the equation. And then +3 plus 6 is 9. So we get 9 for the second row. Last row, if t is +1 instead of -1, then I would get -3 times 1, which is -3, and then -3 plus 6 would be +3, excuse me. Okay, so -3 plus 6 is +3. All right, last column with z. Z equals 0 minus 3 would be our first row. 0 minus 3 is -3. Second row, if t is -1, we'd have -1 minus 3, which is -4. And then +1 minus 3, which is -2. All right, so you can see what we've done is we have 3 different x values, 3 different y values, and 3 different z values that we created based on these t values. When we go to graph this, you can see there's an x-axis, a y-axis, and a z-axis. There is not a t-axis. So the t created our points, but what we're going to do is put these 3 values together. So I'm going to take the x value for the first row, which was 0, the y value, which was 6, and the z value, which was -3, and make those into a point, x, y, z. And I'm going to do that for all of these points, and I'll end up with 3 different points. Then we're going to take those and graph them. All right, so there are my 3 different points. Now, graphing in 3D is a challenge of its own. The best way to go about it, if I'm going to plot this first point 0, 6, negative 3, is to create a box. If you're doing it digitally like I am, you can just grab a straight line tool and that'll help a lot, and then you can use the axes and make them parallel. So I'll show you. Okay, so we always start at the origin, which is where the x, y, and z axis cross, and 0 is our x value. Now x is front to back, but because it's 0, that means that we're not going to move at all. We're going to stay put. So we're going to go to 6, which is the y. It just goes in alphabetical order, x, y, z. And so we're going to go 6 in the positive y direction, which would be this way. 1, 2, 3, 4, 5, 6. Okay, so we're going to go out 6. And I'm going to draw a line. And that's not where I'm going to put my point at, but that's where I'm going to I'm basically tracing my path that I'm taking. So this is kind of like an address or a path. It describes the path you're going to take. So the last step in the path is in the z direction. I'm going to go negative 3. Z is up or down. Now this graph kind of helps you out a little bit because in the black, that's the positive direction, and in the light gray, that's the negative direction. So in the z, you actually go down is your negative direction. So if it'll let me, it's wanting me to move this point. So let me see if I move it back a little bit. There we go. Now I'm going to go down negative 3. And this is where it gets a little bit tricky. If you need to, you can kind of come over here, just start from the origin and go down 3 on the z. And this should be the same length and parallel to this one. But you can also, if you're a better artist, some people are better at this than others, but that's what you want to picture is you want to keep this line, because you're going in the z direction, keep it parallel to the z axis. So we started at 0 in the x, so that means we didn't go front or back at all. We went positive 6 in the y and negative 3 in the z. I've followed all 3 of these, so now I'm ready to go ahead and put my point in there. So let me change back to my pencil tool. This would be where the first point is. Okay, the next one, let me do this one in blue. I'm going to go negative 1 in the x direction. So I start at the origin and I go back 1. 9 in the positive y. It'll let me, I'm going to have to go this direction because it wants me to, but notice I'm going to keep that parallel to the y-axis, and I went 1, 2, 3, 4, 5, 6, 7, 8. Oh, looks like I need to go just a little more. One more. 9. Okay, but I put it back here and I kept it parallel to the y-axis. Okay, or if you're doing the digital, what you could even do is draw it on the y-axis and then just move it back to the right part of the graph. You want it to start from where you left off with the x value. And now we're going to go down 4 because negative in the z direction is down. So I could maybe try that. I'm going to go down 4, but I want it to attach over on this side. So that's kind of actually a good tip that I just thought of. But now that you've done all 3, you can put your point there. Okay, so we have this point and this point. Now the last one. Let's see, I'll do this one green. So I'm going to go positive 1 in the x direction, positive 3 in the y. This is getting, it wants me to move these other lines I've created. Gotta get it. Sorry, more of a technical difficulty. Let's see. So if I take that, let's see, would that be 3? Let's match it up here. It's a little bit too far, not too bad. Okay, now I'll move it. So I went positive 1 in the x, positive 3 in the y. Now from here I'm going to go down 2 in the z. Okay, and you can just approximate as well. Although drawing boxes really helps if you have a hard time with this. And I do have a separate video on that, so if you would like more, if this is just not working for you and you do not understand how I'm getting where these 3 points are out in space, let me know and I'll send you my video for graphing in 3D because I do have one of those. But now that I have my 3 dots, I would just connect those dots, and this is my line that it asked me to draw at the beginning of the problem. So I hope that helps.